Rocketry's origins date back over 2,000 years, but it's only in the past 7 decades that we've launched ourselves into the cosmos. There's a reason why "it's not rocket science" means something's tough to crack. Rocket science is truly mind-bending. Centuries of relentless research, development, failures, and triumphs have paved the way for modern aerospace marvels. Who would have guessed that in just 70 years, we'd go from primitive rockets to landing on the moon, observing the Big Bang, sending rovers to Mars, and even kicking off commercial spaceflight? How did we leap from simple gunpowder rockets to the cutting-edge James Webb Space Telescope? In today's video, we're going to take a look at the history of rocket science and the incredible evolution of spacecraft. Let's get into it. Long before space shuttles and moon landings, the first successful rocket flight principles were tested with a wooden bird. A Roman writer, Aulus Gellius, tells us about Archytas, a Greek living in what is now southern Italy. Around 400 BC, Archytas wowed the people of Tarentum by flying a wooden pigeon, propelled by escaping steam along wires. This wooden marvel was an early demonstration of the action-reaction principle, centuries before it was officially recognized as a scientific law. Fast forward about 300 years, and another Greek, Hero of Alexandria, created a similar steam-powered device called an aeolipile, furthering the idea of rocket-like propulsion. The exact origin of the true rocket remains a mystery. Stories from various cultures hint at early rocket-like devices. In the 1st century AD, the Chinese stumbled upon a basic form of gunpowder made from saltpeter, sulfur, and charcoal. During religious festivals, they filled bamboo tubes with this mixture and tossed them into the fires, creating explosions. Some tubes didn't explode, but instead shot out of the fire, driven by the burning gunpowder. Intrigued, the Chinese began experimenting, attaching these tubes to arrows, and eventually realized that the tubes could launch themselves with the escaping gas. Thus, the true rocket was born. The first recorded use of rockets in warfare came in 1232 during the Battle of Kaikang between the Chinese and Mongols. The Chinese used arrows of flying fire, simple, solid propellant rockets, to repel the Mongol invaders. These rockets had a psychological impact, even if their destructive power was limited. Then, in the 17th century, Sir Isaac Newton laid the scientific foundations for modern rocketry with his 3 laws of motion, explaining how rockets work and their ability to function in the vacuum of space. These laws spurred practical developments in rocket design. In 1720, Dutch professor Willem Gravesande was building steam-propelled model cars. German and Russian experimenters began working with large rockets, some so powerful they bored holes in the ground before liftoff. Rocketry saw a resurgence as a weapon in the late 18th and early 19th centuries. Indian rocket barrages against the British in 1792 and 1799 caught the attention of British artillery expert Colonel William Congreve. He designed rockets that were used successfully in battles, including in the War of 1812, inspiring the phrase, "the rocket's red glare," in Francis Scott Key's The Star-Spangled Banner. Modern rocketry took a significant leap in 1898 when Russian schoolteacher Konstantin Tsiolkovsky proposed the idea of space exploration by rocket. In 1903, he published a report suggesting the use of liquid propellants to achieve greater ranges. Tsiolkovsky's visionary ideas and meticulous research earned him the title of the father of modern astronautics. Then, in the early 20th century, an American pioneer named Robert H. Goddard took Konstantin Tsiolkovsky's ideas and made history. On March 16, 1926, Goddard launched the world's first liquid propellant rocket, fueled by a mix of gasoline and liquid oxygen. It might seem modest by today's standards, but that rocket blazed for 2.5 seconds and reached an altitude of 12.5 meters, marking a groundbreaking moment in rocketry. Goddard didn't stop there. He continued refining his rockets, achieving higher altitudes and incorporating innovations like gyroscope systems for flight control and parachute recovery systems. These advancements laid crucial groundwork for modern space exploration. Meanwhile, across the Atlantic, German scientists were making their mark. Inspired by Hermann Oberth, numerous rocket institutes sprung up in Germany, pushing the boundaries of rocket technology. Their crowning achievement was the V-2 rocket, the world's first long-range ballistic missile and the first rocket to reach the edge of space. After the V-2 rocket's invention, rocketry technology skyrocketed. With Germany's defeat in World War II, the Allies captured many unused V-2 rockets and components. German rocket scientists, including the famed Wernher von Braun, were divided between the United States and the Soviet Union. They were astounded by the strides Robert H. Goddard had made. But the United States and the Soviet Union quickly saw the military potential of rocketry, igniting a flurry of experimental programs. The U.S. initially focused on high-altitude atmospheric-sounding rockets, inspired by Goddard's early work. This effort soon expanded to develop medium and long-range intercontinental ballistic missiles, laying the foundation for the U.S. space program. Rockets like the Redstone, Atlas, and Titan eventually carried astronauts into space. The space race officially began on October 4, 1957, when the Soviet Union shocked the world by launching Sputnik 1, the first Earth-orbiting artificial satellite. Just weeks later, they sent Sputnik 2 into space with Laika, a dog that survived for 7 days before being humanely euthanized prior to oxygen depletion. The U.S. responded by launching its own satellite, Explorer 1, on January 31, 1958. This milestone was followed by the establishment of NASA in October 1958, a civilian agency dedicated to the peaceful exploration of space for all mankind. Soon, many people and machines were being launched into space. Astronauts orbited Earth and landed on the Moon with the help of NASA's Apollo program. The launch of NASA's Space Shuttle in 1981 was a game-changer for space exploration. Until then, space missions relied on rockets and satellites that couldn't be reused. But the Space Shuttle was the first operational orbital spacecraft designed for reuse, and it carried a crew. The shuttle's re-entry into Earth's atmosphere was a masterclass in engineering. It approached with its underside facing forward at a steep 40-degree angle, creating a massive shockwave that deflected heat away from the vehicle. Combining ballistic and aerodynamic re-entry methods, the shuttle began its descent at around 122,000 meters, 400,000 feet, where the atmosphere became dense enough for aerodynamic control. It performed precise roll maneuvers to manage lift and steer toward the runway, ensuring maximum deceleration stayed below 2 Gs. But the Space Shuttle was more than just a transport vehicle. It was a flying laboratory. Of its 135 missions, 22 were dedicated to scientific research, exploring everything from microgravity's effects to how ant colonies behave in zero gravity. A significant innovation of the Space Shuttle program was the use of solid rockets to boost humans into space. Unlike liquid rockets, these solid boosters couldn't be turned off once ignited. The shuttle itself had 3 liquid-fueled engines and 2 solid rocket boosters attached on the sides. However, this design had its risks. In 1986, the Challenger disaster occurred when a solid rocket booster's O-ring failed, leading to an explosion that tragically killed 7 astronauts. Following this, the boosters were redesigned to enhance safety. Rockets have since propelled humanity to the far reaches of our solar system. In the early 1960s, they carried spacecraft past the Moon, Venus, and Mars, paving the way for exploring numerous moons and planets. Thanks to these powerful rockets, we now have detailed images of every planet, including the dwarf planet Pluto, as well as various moons, comets, asteroids, and smaller celestial objects. One of the most significant achievements came when the Voyager 1 spacecraft, powered by advanced rockets, left our solar system and entered interstellar space. Today, rockets continue to evolve, with multiple countries like the United States, India, Europe, China, and Russia manufacturing both crewed and uncrewed rockets. These nations regularly launch military and civilian payloads into space. Each country has a rich history of rocketry, featuring a wide array of boosters tailored for different payloads and destinations. Crewed spaceflight is also on the rise. The Russians have consistently used variants of their Suez rocket to send humans into space. NASA has diversified its approach, utilizing both commercial and agency-directed rocket providers. For International Space Station missions, NASA relies on the SpaceX Crew Dragon system aboard the SpaceX Falcon 9 rocket, a modified booster originally used for satellites. Looking ahead, NASA plans to use the Northrop Grumman Starliner spacecraft, which will launch aboard either Northrop Grumman's Antares rocket or United Launch Alliance's Atlas V. Moreover, NASA has developed the Space Launch System, SLS, to send astronauts to the Moon and eventually to Mars. The first SLS launch was the uncrewed Artemis 1, which took place on 16 November 2022. Nowadays, rocket technology is evolving at a breakneck pace, driven by private industry milestones that seem to pile up every few months. Companies like SpaceX and Blue Origin have revolutionized the game with self-landing rockets, making space travel more sustainable and cost-effective. The trend of launching clusters of miniaturized satellites on a single rocket is taken off, thanks to advancements in satellite technology. Rockets themselves are becoming lighter and more versatile, with 3D printing, efficient fuels, and machine learning pushing the envelope of what's possible. By early 2022, space tourism had taken flight, quite literally. Space tourists and commercial astronauts now have multiple options, with systems developed by Blue Origin, Virgin Galactic, and SpaceX. While space tourism is currently a luxury for the ultra-wealthy, it's a trend set to grow in the 2020s and 2030s. One of the most exciting developments is SpaceX's Starship and its Super Heavy rocket. This ambitious project aims to return NASA astronauts to the Moon in the near future and eventually establish a human presence on Mars. That's a wrap for today. Share your thoughts in the comments below. If you enjoyed this video, give it a thumbs up. It really helps us out. Don't forget to subscribe for more fascinating space content. Thanks for watching.